The only suspect to fit this profile was a rare disease that occurred throughout the world, called Creutzfeldt-Jakob disease, or CJD. And for Michael, the symptoms appeared all too familiar.
The characteristics of it were so clearly like Kuru. And we knew that Creutzfeldt-Jakob disease appeared spontaneously in every human population at about 1 per million per annum, but had been completely ignored by scientists. It was so rare.
With only 20 cases ever reported since its discovery 40 years earlier, the scientific community had never really paid much attention to the disease. But Michael and Carlton decided to go out on a limb, attempting to see if this rare disease could also be transmissible.
We were on our own, very much. There was really nobody else at that stage who wouldn't even dream of trying to see if Creutzfeldt-Jakob disease was transmissible.
So they repeated the Kuru transmission experiment, this time with CJD. And after 18 months, to the surprise of the science community, the chimpanzees contracted the disease. And for Michael, the conclusion was now obvious.
The two diseases, Kuru and Creutzfeldt-Jakob disease, were of the same kind. The most logical explanation was that Kuru began in the same way as Creutzfeldt-Jakob disease. And one individual came down with a spontaneous change in their brain and became, sadly, in that community, the origin of this terrible and vast epidemic. Transmission of Creutzfeldt-Jakob disease was a very exciting outcome, because this clearly indicated that our belief that Kuru would open up a new area of human medicine was justified.
Michael and Carlton had now linked 3 transmissible diseases. Their chain of discoveries was setting a new course for human medicine, and they now gained the recognition from the world's scientific community.
These are very exciting times. I mean, intellectually very exciting. You know, we'd achieved a lot, and it was clear that this probably meant a Nobel Prize.
The rewards are bigger for medicine than they are for anthropology. There was always the odor or the smell or the promise of a Nobel Prize in Kuru.
When Creutzfeldt-Jakob disease was transmitted, Carlton changed somewhat, because I think he knew that there was a Nobel Prize. More and more he was spending time giving lectures, going around, making sure that everyone got the message about what had been achieved.
With his eye on a Nobel Prize, Carlton then concentrated on trying to identify the culprit. The agent causing these diseases was unlike any virus or bacteria known to science.
It had very weird properties. Those properties continued to be more and more weird as it was investigated.
Carlton's team discovered that the particle causing the disease was 1,000 times smaller than any other known infecting agent, and found only in the brain and spinal cord. But exactly how it caused the infection was still a complete mystery.
But I couldn't find an antibody, and we still can't. So everything about it is unique. The rule is still today that every infection on Earth produces antibodies. No exception on Earth. No AIDS patient on Earth. Catch on? That's the important rule. So I called it an unconventional virus.
And in 1976, Carlton finally won the Nobel Prize for his discovery of what he called an unconventional virus. But he wasn't the only one hungry for a Nobel Prize.
I didn't think these particles were viruses. I didn't think they were slow viruses. I didn't think they were unconventional viruses. I thought they were different.
Bullshit. It's a virus.
However, biochemist Stanley Prusner disagreed and gave Carlton's virus a name, identifying it as a protein particle he called a prion. starting one of the most bitter rivalries in science.
Stan says, it's not a virus, it's a prion. That's not a discovery, that's a word.
And you have to realize that this was the first new pathogen in 100 years. That we knew about viruses and bacteria and parasites and fungi for 100 years. So there was not a lot of I should say, happiness associated with the introduction of this term on the part of a lot of scientists. They were really quite antagonistic.
Prusner would have to wait another 20 years to win his Nobel Prize. His findings turning the world of science upside down.
Prions cannot be classed as living organisms because they contain no DNA or RNA. And therefore, how can they reproduce? And if they're not organisms, how can they cause disease?
Prions ignore the rules of normal biological reproduction. They recruit rather than reproduce, targeting normal proteins and converting them into replicates of themselves. These in turn attack and convert more, building ever-increasing numbers that kill cells in the brain.
So now we had an entirely new disease paradigm that evolved out of these basic studies and the discovery of the prion protein.
Whilst two of the world's top scientists squabbled over what to call the infecting agent, Michael was back in Papua New Guinea, where large numbers of foray adults and adolescents were continuing to die, even 15 years after they had stopped eating their dead.
Other people were forgetting about Kuru. Kuru is something that had done its work, as it were, and could be forgotten about. But that wasn't true for me. We had to continue with the epidemiological surveillance to follow the epidemic, to find out, in fact, how long it will go, to establish the possible length of the incubation period in a human prion disease.
The determined Australian decided to remain in Papua New Guinea to record every case of the disease. But just how long could these extraordinary incubation periods extend? And for how many years would Michael have to track the Kuru epidemic? In 1984, 25 years after the cessation of cannibalism, close to 30 adults were still dying of Kuru every year. Incubation periods were reaching lengths way beyond what Michael had ever imagined as possible.
I had no idea how long the epidemic would continue. In the literature, there's the statement that we have to continue for another decade. And every decade we kept saying that.
Fear has quickly spread through Europe.
And then, in 1985, a modern cannibal practice hit headlines around the world.
Sending shockwaves through an industry worth some 50.
Then came BSE, mad cow disease. Was clearly in the same group of diseases as Kuru, Creutzfeldt-Jakob disease, scraping. And of course, the analogy with Kuru and the consumption of the dead was immediate, because of this practice of feeding calves meat and bone meal, which derived from brain material and spinal cord at the abattoirs. And that we know with Kuru that they are the infectious parts of the body. And the big question, of course, was it transmissible to humans?
And it was 10 years after it first surfaced in Britain that mad cow disease was found to have crossed over to the human population. Called variant CJD, there have been over 150 cases in the UK since 1995 from eating infected beef.
A large majority of the UK population has potentially been exposed to BSE. We don't know what the infectious dose or the lethal dose that you need to be exposed to develop the disease is. We don't know what lies ahead. We don't know how many people are actually silently harbouring the infection.
Professor John Collins spearheads the research into variant CJD in the UK. One of the first people he contacted for help was Michael Alpers in Papua New Guinea, where remarkably he was still finding 1 or 2 Kuru cases every year.
The natural thing to do was to turn to the only other known human epidemic of prion diseases, which was Kuru.
Long Kuru na imi come down na mi pelama mas Londispilla. So me work yet Londispilla, long Australia. John Collins and work yet long England.
Kuru's been of immense interest to everyone working in the prawn field for many years. It's of enormous historical interest, particularly about the range of incubation periods. We're particularly interested what the upper limit of that might be.
We have documentation on every case of Kuru that's occurred. So it's the full record of a disease. And we knew that in some cases, Kuru could have an incredibly long incubation period of over 50 years.
Michael's work is now providing the foundations for predicting the outcome of variant CJD in the UK. But the fact that this was transmitted from cows to humans means incubation periods could be even longer.
When you crossed a species barrier in transmission, you tended to double the incubation period. So this means that there's a real possibility of incubation periods in variant Creutzfeldt-Jakob disease of up to 100 years, beyond the normal human lifespan. And that's a big worry from the public health point of view. Because Kuru, BSE in cattle, that's a disease of the brain.
Variant CJD is not just a disease of the brain, it's a disease of the lymph organs.
It's in the spleen, in the tonsils, in the gut, and in the blood.
And this means that there is a risk that the disease could be unknowingly transmitted by blood transfusion or organ transplants. And indeed, there already has been transmission from human to human through blood.